Hi, welcome to week 6. This week we look at chapters 16, 17, and 18, air pollution, water use, and water pollution. These are really timely and relevant activities that are going on right here this summer in San Diego. Many of you are probably familiar with the idea of air quality and what happens when our air quality drops. This is, of course, a photograph of a city under the influence of smog. And one of the things that I want to point out to you in this particular picture is that you see that there's a line of demarcation here where the air is clearer on above that to where the smog layer is. And this is actually a temperature change that happens here. This is an inversion layer where you actually end up with a warmer layer sitting on top and holding this down like a cap. All kinds of different components in air pollution. As you go through the chapter, you'll study more details than what I am providing. But you see here just some examples of a few of the gases that we would normally find in different kinds of air pollution and what some of the sources of those gases happen to be. Of course, this is the idea of the inversion, where you see this temperature change. Normally it's going from, as you go up in altitude, it gets colder, but you see here what's happening is that it gets colder to a point and then actually warms up. That's this transition area right in here, and then it continues to cool above that. And this creates kind of a blanket, a lid kind of effect that can trap pollution. So we often see this, for example, if you get out in San Diego early in the morning, you can see this in some valley areas. Like if you ever drive into El Cajon, you can actually see that layer. This week, of course, we had the horrific fire on board the Navy ship, the Bohum Richard. And people complained about the smell of the smoke, and people were actually advised downwind of this fire to stay indoors. And so air pollution is a very real and ongoing problem, and this is a great example of how this environmental science class is very timely. These things are happening right here in San Diego at the moment. If we switch and look ultimately at water, what's the water sources for San Diego? This is one of our sources. This is the preface of the chapter, the case study that you might want to pay a little attention to. San Diego would be located just about here to the left of the diagram. This is Imperial County right here, and this is the Colorado River with Arizona over here. So this represents what is known as the Colorado River watershed. And the water that starts off in Colorado and Utah, and it makes its way all the way through Arizona and is shared ultimately by these 4 states. As Arizona became more populous, then they wanted their fair share of the water, making less water available to California. And so this has become an interesting problem. You should always know where your water comes from and kind of the quality of the water. If we look at the distribution of precipitation around the world, you see that the darker blue is high levels of precipitation. So we have like the Amazonian river basin right here in South America and part of the jungles of Africa and Southeast Asia, where they get a tremendous amount of water. On the other end of this scale is going to be the sandy colored area, which are the driest parts. And so you see, of course, northern Africa, the Sahara Desert, the Gobi Desert of China, and of course the deserts that we have in the southwest part of the United States. And you might actually look up here too to see that are there deserts in the Arctic area? Now, interesting question. And the answer is that it's not really desert, it's just areas that get very low precipitation. So it's a very, very dry and arid area up in that region as well. Water quality is an issue here in San Diego. One of the things that we're dealing with is the shared resources with Mexico, and what happens when Tijuana, our neighbor to the south, has trouble with their sewer systems, and they dump their sewer, and it ultimately flows to our side of the border and out into the ocean, where people of Imperial Beach often aren't able to enjoy their beach to the fullest. People are prevented from surfing. So again, very real problems. This is what the Tijuana River looks like, not from your textbook, but when we have these channels and they get overrun with all kinds of trash, and there's human feces, waste, and materials in there as well. As that material makes its way into the ocean, a whole bunch of interesting things happen. Again, I'm only giving you a brief introduction here, but one of the things that I want to talk about is the amount of dissolved oxygen. So if we have dissolved oxygen in the water, it can be actually a pretty rich area, but where you see the oxygen being depleted, and particularly if you get into this oxygen sag zone, it's an area that doesn't support life very well. And to bring this up and report this to you, a month ago we were experiencing a pretty phenomenal red tide in San Diego, causing bioluminescence at night in the water. But the organisms that were responsible for that ultimately die and are fed on by bacteria, and that whole process uses up a whole bunch of oxygen, and we saw a tremendous fish die-off. One of the other problems that we have, of course, with water pollution is what ultimately gets washed into the water. And so here you see a harbor seal that's become entangled in the remnants of a fishing net, and if some good-hearted soul doesn't help this little harbor seal, they'll be destined to die. Most people kind of aren't really aware of where their water really comes from or what happens when they flush the toilet. In cities, we flush our toilets and they go into a main municipal sewer system, which then flows to treatment centers where the sewer is actually cleaned. In San Diego, we clean our sewer to a level 3 and then return it to the ocean. This is a house that's living away off the grid, off of the municipal water system, and you see that what's happening here, this is a septic system, and so the people that use the toilets in this house, it flows out into their yard. This is actually buried, and it has different layers of it, but this is actually a buried phenomena, so they would have grass over the top of this, but you would see that the solids would actually settle down onto the gravelly surface. The liquids would be above that, but they would ultimately seep into the soil. And it's not uncommon that people who have septic systems also have wells. And it might be that right over here to the side of the house, maybe where my pointer is, somebody might have actually drilled a well. And that well could be being filled up by contents from their septic system that have been purified as they've passed through or leached their way through the soil. So that brings up an interesting question about recycling sewer water. And there's a big effort in San Diego to do this. Currently, the acceptable, inside the San Diego city limits, the acceptable use of reclaimed water is for irrigation. And this water is supplied to parks and industrial areas in what is known as purple pipes. It's often referred to as purple water. The water itself isn't purple, but it comes through purple pipes to represent the fact that it's supposed to be non-potable. And so the idea is to reclaim the water so that we can reuse the water. So one of the great big controversies right now is a process what is known as toilet to tap. And here you see this person is reading the newspaper, and they're talking about how the city plans to recycle water for drinking. The dog, of course, said she's been doing that for years. One of the assignments that I want you to do this week is to research this idea of toilet to tap. It's actually being done in Santee, a suburb of San Diego, And so I want you to look at that and argue both in favor and against that with supported data references, and so that you have an opportunity to apply some of this. So hope you enjoy the chapter, and we'll keep working along. Bye.